So this is the scenario that I actually gave you to take home and work on. This one here I chose to use as the example for number 6. It's different than the one you're working on if you have the ice cream truck, but it's the same concept. So you're going to still apply the same one. What you need to do is you need to identify which one is Angel and which one is Renee's route. For this case, Angel wants to walk through the street and Renee wants to walk directly through the grass. She thinks it's faster. So we're going to find out if Angel or if Renee's faster. The difference with this one is we have our leg. It's back at the original spot with the snow cone stand. So our first leg will be 457.4 feet. And then our second leg is 287.2 feet. But this is all going to change because now we're talking about what if they run diagonally from the tree to the snow cone stand. We have the distance for the diagonal. They say that it's 400 seconds. Okay. We are sitting here, we're talking about running. And to find the distance for running, we need to find out through grass how far we go. So let's go ahead and flip. For running on grass, it's 4 feet per second. So we're going to put grass. And we're talking about 4 feet per second. To get the seconds, when we had the feet, we divide. Now we're going to do the inverse. We have the second, it's 400 seconds, but we need to know it in feet. In this case, we're going to multiply by 4 because it's 4 feet per second when running. If I take my calculator, for this one, I'm going to do 400 times 4, and I'm going to find it's 1,600 feet. This is my new hypotenuse because in this story, Angel and Renee decide to run around the tree one more time before running to the snow cone stand to get a snow cone. If it took 400 seconds to run diagonally from the snow, how far were the picnic baskets? So in this case, it's 1,600 feet. What that does is we still have this leg, but this leg changes because now it extends all the way to the tree. All right. I need to use the Pythagorean theorem to find the leg. I have my leg here with this measurement. I cannot use this leg because it's here. This additional feet is not going to tell me the total length that reaches my hypotenuse. My hypotenuse extended to 600 feet. So in this case, we're going to call it our B, which is our unknown. I'm going to slide this a little more. I know you won't be able to see the top, but you will see my work. I have a squared plus b squared equals c squared. That's my Pythagorean theorem. Okay, I'm going to use my a as 457.4, and I'm going to square that. I'm looking for my b, and then I'm going to solve using the c that I found. When you solve, don't forget to do the inverse and solve for b. Okay, and this is going to be in feet. Once you solve for b, you're going to have the distance of the whole leg. But it asks how far from where they were to where the tree is. You need to find this portion. The way you do that is if you have this whole leg, you can subtract the old leg, this part here, which is this, by the new leg to find the distance. That means that my b, whatever this equals, I'm going to subtract that by 2 87.2 feet, because that's my O leg. If I were to cover this up right here, my O leg, I'm going to get the distance from here to the tree. So when finding this leg, I will put that value there, subtract it, and that will equal, in feet, this will equal, well, I'll put a question mark, the distance from the basket to the tree. That will give you an outline to solve any of the problems that are number 6 on your mock performance test.